Hey, hello, hello. I'm Dave D. Hilster, and you have joined us for our Saturday Science Chats. I want to thank and welcome all my subscribers from Dissident Science, and also everyone from the John Chappell Natural Philosophy Society. Today we have a great show. You don't want to miss it. It's going to be another fantastic session. Big bang or big bust. Hello, hello. This is David D. Hilster, and I am here with our Saturday morning chats. And I guess my subscribers are starting to get used to this. They've been used to all these videos that I've been doing. I am off this week and for Thanksgiving from my regular job. Yeah, I work like most people are working for their regular jobs. And I am going to be, I promise I'm going to make a new video for my Dissident Science channel. I've got lots of topics to talk about, but I do appreciate everyone coming by and me broadcasting live to both the Dissident Science YouTube channel and to our CNPS, or the Chappell Natural Philosophy Society. And of course, these are Saturday morning chats. Again, I want to thank Franklin Hugh and all the crew that have been doing this for the last couple of years. We've actually been doing this in one form or another since 2008. And one of the first people we talked with was actually Yonel Deneau, because that's when I found about his underwater experiments, which of course are absolutely a must for everybody. In fact, I coined this. I can say that the Deneau effect. Yeah, he came up with I call the Deneau effect. So, but anyways, so we've had a tradition here at the Saturday morning chats. And of course, the CNPS's mission, that is the John Chappell Natural Philosophy Society's mission, for those, especially those people on my channel, don't know what that is. We are an organization that above all promotes critical thinking without malice. And we know that's not always easy. To be an organization that supports, publishes, and promotes serious scientific work outside the mainstream. Note on serious, to provide a forum for open debate about modern topics in physics, cosmology, philosophy, and mathematics. And we also talk about some other topics like structures, which is a really great topic. And to provide a forum for presenting serious papers and theories without fear of censorship. And most importantly, we are run and controlled by our membership in its entirety. So that's very important. Of course, you can join our community online by going to naturalphilosophy.org. Yep, we procured that domain. It wasn't cheap. Actually, naturalphilosophy.com was way more expensive, in the thousands of dollars, but we put our money together and grabbed that. We feel that we are the best organization on the planet to own that. And if you go to it now, you will see a really wonderful new system. We use Buddy Boss in WordPress. It's subscriptions, everything's subscription now, everything. You can get it for free and use it once. Nope, people are making money. That's why everything's subscription. In fact, eventually, I think that's all we're going to be paying. We won't be paying bills. We'll be just subscribing to everything. But you do want to check it out because it's a lot of fun. And we have, you can get in there and argue. I'm going to talk a little bit about that today. So check that out. If you haven't, sign yourself up. And of course, how do you can participate with this group? How do you meet the people who are the critical thinkers, the Copernicuses, the Galileos, not the Einsteins, the Newtons of the world? How do you participate? You can sign up at naturalphilosophy.org and consider becoming a member. And I want to make a plea again. We've got a big bill coming up. It's over $700 for our website. Yeah, that it's not that much per month if you think about it. Divide 700 by 12, but we need to pay that, and this isn't free. So if you've been using this and enjoying this, just sign up as a member, and you can pay an annual fee. I'm going to actually put up some. I'll be putting up some monthly donations, like $5, $10, $15 per month. Sort of spread it out, but we need your support to keep this going. It is not free. It's not like we used to have, 10 years back, and I had a server and everything could run off of it. And we didn't. Now we have StreamYard. Like we have here. We have our online overleaf where we publish everything. We're publishing George Coyne's book. It's going to be coming up next week. Hopefully, we'll get that out there so you can George Coyne, one of the great philosophers of our time, as well. And we also have the software software that we use on our site, which includes membership. I mean, the membership software that gets out and be able to take your payment, all that stuff, all that costs money. So please, 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 especially if you've been using this, seriously consider it, because truly, if we can't pay for it, we're not going to be here today. And today and age is all virtual. So greatly, greatly appreciate it. Of course, you can participate in our discussions on our website, and you can also post and to help us out by posting news and happenings about us on social media. Our websites, of course, you can go to is naturalphilosophy.org. That's our community website now. Our online magazine, Science Woke. If you're new to this, if like you're from Dissident Science Channel and you've been subscribing to me and you don't know really what are the problems in physics, wow, you can go there and there's a problems button there, and you can see all the areas where there are problems and all the amazing critical thinkers who have been addressing those problems, like the Big Bang, which we're going to be talking about today. We also have our our own Wikipedia based on MediaWiki, which is the open source Wikipedia software, and that's available to you. So if you're a scientist, especially, I know we have new people out there doing new work. We've interviewed some of them, and I've talked with them. You can get your profile on there. Just contact us, and we'll get you a login. Because no, it's a closed wiki. Why? Because Wikipedia is a consensus. It is literally the consensus knowledge of the human race. Why is that? Because I can go in and edit the Big Bang and put a whole section in there why the Big Bang is wrong. But of course, you will be edited by what I call the science police, physics police, because that's not the accepted theory. And unfortunately, Wikipedia is not good at allowing critical thought or criticism, which it should. Every theory, everything out there should have a section as to the problems, but they don't do that because it's a consensus website. And I'd be very embarrassed if extraterrestrials came our way and landed and took a look at some of the ideas that we think are right in mainstream science. Oh my gosh, that's very embarrassing. Even Einstein, who's wrong. I mean, who's the Einstein guy? They'd probably fall off their alien chairs. Okay, and we also have coming up the Chappelle University with courses in natural philosophy, and Glenn Borchardt is going to be giving a course and having a course on there. He's already starting to prepare. We're working with him. My father's going to be doing one on the particle model. I'm going to do one called the particle model for dummies. We should do that. Hey, Glenn, we should do infinity for dummies, right? I'm just kidding. It's a marketing ploy. It seems to work. But also James Maxwell is going to be he's going to be also creating courses. So it's just great. I'm going to get George Coyne to do it too. I mean, we got top hitters up there, and we've got the whole structures, on and on. So you don't want to miss that. It was founded in 2018. And we still haven't opened the doors, but we are on our way. And we got great software. We're using LearnDash, so you don't want to miss that. Critical Thinker Science News. I've changed it, not just my thoughts. So this is David Hilster from CNPS and Dissident Science. And I'm going to give you a little bit of news update. I used to do this on my YouTube channel, but it's a lot of work, folks. So in the morning here, I try to look around what I've seen during the week and sort of try to post it here. So if you look at our forums, they're always on. So if you look at the front page, you click on it, the activities page, you're going to see what's going on, who's joining, what people are saying. And Ether and Dark Matter are going out there. John Eric Pearson is going at it with James, talking about the ether theory and apparent empty space. You can see some of the comments there. And then I even jump in there with saying, hey, dark matter doesn't exist because Newton explains everything without having to invent any type of... But anyways, it's a discussion. None of us are right. None of us are wrong. It's a discussion, and we're trying to find truth out there. So you want to get in there and see that. So I've seen some of that. Here's an interesting thing that I just did yesterday or the day before. Can't remember the days anymore. I'm just like everybody working like crazy. But I was talking last week with James Maxwell, who's a Spanish Tectonics and Expanding Earth. And I came up with this. I've had this idea for a while, but let me explain a little bit about it. Again, this is sort of in the news. GitHub, what is GitHub? I'm not a software. GitHub is a place where you put software, programs that everybody can have, that you can run, that you can download, you can modify. You can modify, and if you want to make an improvement on that, you can download it. You can fork it off, as we can say, like a fork in a road. You can fork that software off, go in, make your edits, put it back, and people who are running the GitHub repository, the repository of all these things, can say, Dave, that's a stupid thing. We're throwing that out. We're not going to let that go. Oh, or great, that's great. So what did I do? Because I live in that world, I am a software engineer in the area of natural language processing, artificial intelligence, big data, all that kind of stuff. Lots of names. But we have this, there is Google Earth, and I went in there and I did this. I put in a new issue, an issue or items of new things you want to see, like new features, or you want to discuss something, or you in the issues is something's broken in the software. So in this one, I said, looking to fork Google Earth, that is to make a new branch of Google Earth to be able to change the Earth's radius and overlays with time in millions of years. Can you imagine that? Oh, so you just have the same thing, except that when you would change the time, you type in 50 million years ago, the Earth would shrink down to the size that I put the graph in there. You can see here, of course, the graph. I think I can have a pointer here, can I? I should get my pointer. I'm sorry, folks. You can see this little guy, but there should be a pointer, but I'm going to do that live now. Anyways, I put in the graph. Oops. Sorry. Let's look like I can scroll down on a slide. I think what am I on today? Anyways, here is the graph that is we have an equation for it with James Maxwell. And so here's what I said. I said, we are a group of geologists, scientists, engineers, and computer programmers who are looking to fork Google Earth software to modify it in order to be able to change Earth's radius and time and be able to plot flora and fauna and geological information on it. For example, 200 million years ago, there's diameters about half the size. We'd be able to change the time on the model and therefore the radius and its overlays. This would allow many scientists around the world to see new relationships with geology, paleontology, biology, and much, much more using the theory of expansion tectonics. I'm wanting some guidance on how to do this. I'm a computer programmer, blah, 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 blah. Is it possible? Is it hard? Can we overlay the database? All we'd have to do is add a new thing, a column to the database saying, oh, all these things you're plotting on it, well, it just now has a time period. And so that's really interesting. So that's out there. What will happen? I don't know. Nobody's responded yet. I'm out there all by my lonesome. But you got to start somewhere. Another thing, again, what I'm doing is I'm showing some of the things. Actually, these things are in our activity area. People will put stuff there. I put stuff there. This is a real interesting one on expansion tectonics from last year's topic. If you take an orange and you cut it up, you got to watch this, folks. In fact, DOMINIK only has 5 subscribers now. He just started. I want you, give him some love out there. Go and subscribe. That's the way it works now. It's like you don't go and read a person's paper and put it in a proceedings and then reference it. That used to be the thing. Now it's going and watching the person working, talking, and going there and subscribing to that person's work. So give this person some love, as we say, and subscribe, thumbs up, like on these videos, take a look at it. This is a really great idea. I've been trying to come up with an idea like this. You take an orange, he cuts it on it's a smaller thing, and then he cuts it in a way so he sort of outlines the way the continents are, and then he opens it up and pins it onto a bigger ball. That's pretty cool. I mean, I've seen a lot of things, but this certainly wins the award. You want to check that out. Again, DOMINIK, pretty cool. Critical thinker, got some pretty nice things going on. Another person out there who's very new is Ray Fleming. And of course, we know all the people I've been talking about for many years. You got Borchardt and all, Maxwell, all kinds of people out there. But he's a new thinker. And if you're one of those people who are into the positive and negative charges and fields and all that, here's the strong force is electromagnetic. So this is one of his ideas, and he does his little lectures here. You want to take a look at that. It's growing. Go again and give him your thumbs up, subscribe, that kind of thing. That's, again, how we support. The more you get that, the more people will watch it. So it's pretty cool. Again, it may not be your cup of tea, but even if it isn't, support people. One of the things is, folks, I don't care, I'm not an etherist. Glenn Borchardt is an etherist. I am a student of his work, will always be. He's going down in history, or in my opinion, he's already in history. And so we can disagree on things or have different models. But first, most important, we got to support each other. I mean, everybody wants everybody to, take a look at your model, right? If you have the infinite universe theory, you want people to look at it. But if you just want people to look at yours and you don't look at others, then that's not cool. No, well, how would you expect people to support you? Because everybody has ability to watch things. Okay, my father, particle, I remember we started making videos. He's, oh, ran out of ideas. Boy, that's not happening. He's actually came out with 2 this week, so you want to give him some love. Particle Guru. He's got 370. He's going up almost to 400 subscribers. You can go to youtube.particle.guru, not .com. Yes, there's actually a .guru, so you can get that. And he talks about perpetual motion, because our theory supports perpetual motion, motion without any type of force from. No, I'm kidding. I'm kidding. Now it's going to be like somebody's going to take that part and take it out of context. No, I'm just kidding. So he talks about that. Interesting. He also has another one on the hydrogen spectrum, again, using our particle model. So if you're a person interested to see how one person sees the universe with a new model, check it out. He's also going to he's also putting together a course. And of course, we are finished. We're finishing our book and always will be. No, he's probably listening to this. No, we are in our final push. I'm on Thanksgiving vacation. I've taken some vacation days off. Half that day is going to be spent finishing up the book, mostly graphics for our book called Principia Mathematica 2, which we extend Newton's Principias ideas. It's a neo-mechanic. It stands on the shoulder. If Glenn Borchardt didn't exist, this would not exist. So we're doing and we're going to also have an ether discussion. So I don't recommend Glenn watching that. I'm kidding. But anyways, it's going to be really cool. So you want to check that out. Again, this is for people in our community. It's on Monday. It's at 1:30 p.m. It is the sort of Thanksgiving break. If you miss it, of course, it's all live. So it's all recorded, just like this. And of course, we want to just take Dr. Alexander Unziker. I highly recommend you subscribe to his channel. He's got over 4,000 now, 5,000. I don't know. Keeps going up. He has a doctorate in physics, and he is a science writer, critical thinker, and he puts people's I'll say shoulders to the walls, because there's actually another saying in English, but I want to keep this nice for him. And he. During one of his talks during our conference, our in-person conferences, when those existed until we are now in a permanent plague state. Anyways, he said to people, he says, well, I'm working on my theory. He says, keep working on it. Just keep working on your passion. So if you're an electric universe person and you think everything's electric, keep working on it. If you're an etherist and you think it's ether and trained ether, or ethers that moves up and down, or your particle model like us, where waves are particles traveling together at the speed of light, whatever it is, you keep working on it, and we'll support you. That's what we are here for. But not really today. That was the news. I'm hoping that's sort of nice, because a lot of times what I feel is a lot of people who even come to these videos, they don't know what's going on. So I'm going to try to do that every week. Like I don't have anything else to do in my life. Anyways, I will do it. Someone's going to do it. So that's my news. So today we're going to be talking about the Big Bang or bust, and with Dr. Glenn Borchardt. And of course, if you don't know him, he is a geologist and scientific philosopher. He developing in the infinite universe theory, and he has many books, and he adapts classical mechanics to infinity. That's what he's done. This is bigger than big. So many people have come to the same conclusion, but he did, and he put it in a formalized way. And of course, if you don't want to take my word for it and really read about yourself, or want to subscribe to Glenn Borchardt, he has this. He has the scientific philosophy website and his blog. And this is an old one because there's actually a newer book, but that's okay. I keep making him come back. So I want him on the show again. So I don't want to tell you everything. Anyways, go there and you can see he's got really great blogs. He takes people's questions about things like the Big Bang, dark energy, that kind of thing, and he rips them. I mean, he discusses them. And if you want to know more about Glenn, go to our Wikipedia, look up Glenn Borchardt. You can also go to Science Woke. So if you're not into the super technical stuff, maybe you can go to our Science Woke website. And Mind Blown, you get things like that. Social media replaces the Big Bang with an infinite universe. Oh my gosh, that's what I'm going to be talking about today. But we're not going to be talking about the infinite universe theory. We're going to really talk more about the problems with the Big Bang. And of course, I got his. I'm not going to read this. He's been on before. I will go and I will show you here some of his book. One of the great things he's given us are the 10 assumptions of science. In my opinion, a must read for everybody. You make sure, are your ideas consupponable? That's my favorite. I mean, I'm a linguist and I love that word. I'm going to make I'm going to make a t-shirt out of that. Are you, are your thoughts consupponable? Can I say it? But if you haven't read the 10 Assumptions of Science, it's actually embedded in his other books as well. But if you can get that one, I've got one. So it's a rarity. Pass it down to generations and make some money off of it when it's famous. Scientific Worldview, in my opinion, his opus book. His book that really, and it says beyond Newton and Einstein. Of course, it's interesting because the truth is, it's beyond Newton. And it's not really beyond Einstein. It's more like goodbye, Einstein. So that's pretty interesting. But of course, it's marketing, and you don't want to put an Einstein with like a knife in his forehead with blood coming down. That would not be cool. But anyways, this is one of the great tomes of all time when it comes to scientific science. A must read. He also was part of the universal cycle theory, which it really was a seminal book for myself because that's where I really understood neomechanics, where he took the Newton world and put it into in the infinite world where turtles all the way up and turtles all the way down. In fact, this cover is interesting there. If you look at that cover, it looks like, oh, there's a red dot going around some kind of galaxy. No. If you read the book, that red dot is our known universe that's going around something else. Can you imagine that? Well, it has been imagined. It's been imagined by Stephen Putz. I'm going to call him Putz. I'm sorry. And Glenn Borchardt. But it's a great book as well. But of course, if you want to know the infinite universe theory and what we're going to be talking about on another day, because I was looking at what Glenn sent me, and I said, Glenn, this is just so much stuff. I think we need to have another talk about that. So I want to concentrate on the Big Bang. And but you can read about that. It's an alternative to the Big Bang Theory. And again, I guess today I want to really talk about the play bumper. See, look at that. This is where I always forget it. So play bumper. Do what it says, Dave. Well, I have right next to me here Glenn Borchardt. If I could get the stupid thing to work right here, I've got Glenn Borchardt, who he is a real trooper because he's saying, Dave, it's early here, and I said, yeah, it is. I don't know what's worse, 11 p.m. to 1 a.m. in Perth or 7 a.m. to 9 a.m. in California, but you don't live in a very suffering place. I watch you on Facebook, and it is such a beautiful place. Where are you coming from?
Tahoe.
Tahoe, yeah. See, this is what you want to be. You want to be a world famous scientist retired in Tahoe with all the snow and all that beautiful stuff. So let's get a little closer here. Yeah. Well, thank you so much again, Glenn, for coming on.
Yeah, well, thank you for having me on again. It's great, really great.
Yeah, no, I mean, I'm really excited because you sent me all these slides for your class coming up, and I think it was almost 200 slides. I'm thinking, whoa, this is a real course. So we're going to be working on that with LearnDash, but I've got some stuff I sort of cherry picked because today we're going to be talking about the Big Bang. So I thought maybe what I can do, and again, I see there's a ton of comments. I've got what 50 some comments already. But what I want to do is I'm going to go through and I've brought some things up to sort of get things started on the Big Bang specifically. So let me bring these up for you. Big Bang in the news. So what I did is I went to, you can go to news.google.com and you can look things up. In fact, you can click on physics if you want. And so I just decided to click on the Big Bang. And again, it's interesting because physics pin down nuclear reactions from the moments after the Big Bang. I always marvel at this, the moments after the Big Bang. Like, I mean, you've got people on planet Earth who are basically, discussing the picoseconds after the supposed Big Bang. Of course, why did it explode? All that kinds of thing. And here's another headline you see today: as the ultimate, astronomers want to put a huge telescope on the moon to study the Big Bang. I mean, Glenn. I mean, even just oops, wrong button. I'm just going to bring you this back up. Remove. Here we go. There. Oh, look at that. See, now that should be the same size. There we go. Let's just talk about, and we got a lot to talk about the Big Bang. I have a lot more slides here, but I mean, the idea, they want to put a telescope on the moon to study the Big Bang. I mean, where do they get these things? What does that mean?
What does it mean? Well, they get lots of money. That's what it means. You get to put the thing
Ah,
on the moon, and you're
that's
not going to see anything about the Big Bang because that never happened. But what you're going to see is other stuff, right?
right,
You're going to find
right,
that space is not empty. There's all kinds of stuff in
right.
space. And what else are they going to see? And they'll make up some story so they can get funding again. But it's like the Higgs boson, same thing, where you find one little tick and you get a Nobel Prize for it. And it's given to you by your buddies. So hey, that's what they
Yeah.
do.
I mean, it's such a setup, right? I mean, even with like the Higgs particle, right? Here's the guy. Here's what we're gonna do. It's or like it was gravity waves was the last one of the last ones,
Sure.
right? Gravity waves, and the only person that's still making a living off of relativity is Kip Thorne. I mean, he's if you try to find anybody else that's really says on relativity, it's him. And so you can see the scientific community setting up the next Nobel Prize. They're going to tell you what's coming. They're going to tell you that they're going to find it, and lo and behold, they find it. So what you're saying basically is when you look at a headline like they're going to send something to the moon, what they're really doing is getting grants, keeping jobs alive, keeping scientists going, keeping engineers working, and you're not going to hear too much about the actual thing. And I think maybe you'll agree with me. Anytime, this is one of the things people don't understand. There are certain words that will get you a lot of attention in mass media, right? If I
Sure.
say to people, monopoles versus dipoles, no one's going to listen. No one's going to hear. But if I say the word Einstein, everyone is going to read about it. And if I say Big Bang, everyone's going to think about it or read about it. Don't you agree? There seems to be certain trigger words, and Big Bang really seems to be one of those in mass media.
Yeah. And I've done this in the book. I actually had a little engram, from Google
Oh, I've got that
where the
coming up.
mention, yeah. And it shows, it's kind of interesting. The expanding universe started way before the Big Bang. Big Bang has really gotten popular since 1970. So as a
Right,
buzzword,
right.
that set before 1970, not much. Yeah.
Oh,
Okay.
look
There
at
you
this.
go.
There we
Yeah.
go.
Yeah. See, the
Yeah.
red
So
line is the expanding universe,
right,
and that's 1930s and so on. That's,
right.
when that was first, Hubble's work, and misinterpreted as expansion. And then, as you can see, the blue line, there's the Big Bang Theory, and that gets going in 1960, 70. And then,
Well, yeah.
uh,
Wait a minute. Before that, well, because the Big Bang. I mean, Hubble and those. I mean, that wasn't the. Why did it take off in the '60s? Wasn't it? Wasn't that the idea before then, or not?
that's interesting. I think really, the big book on it was printed in 1950, I think. So you can see
Right,
it kind of starts from there. It takes 10 years for a book to get going
right, right,
and
right.
get popular, and so
But the Big Bang
Lemaitre.
was really around since the 30s, wasn't it?
No, look at it there. You don't see it. You don't see anything before 1960 in that blue line. See it there?
Yeah, yeah,
Yeah,
yeah,
there you
yeah, right
go.
here. Yeah,
Yeah,
yeah.
yeah. So actually, Lemaitre's book was like in 50, and it didn't really. And see, the
Yeah, it didn't
steady
take off.
state there was
Right.
in action prior to the Big
Oh,
Bang, which
right.
was, remember,
1950
that was
or even the
what was
20.
overthrown by the Big Bang.
Right, but it's still around. They talk about maybe it's more. It's interesting here in 1980 how you see almost this takeoff here of the Big Bang really goes up and the steady state actually starts to go down. I
Yeah,
think it's probably just listed for because of the its comparison probably right when they're teaching. Well, it used to be the steady state. So you probably
yeah.
hear that in and it's also interesting here is a multi-verse and parallel universe.
Sure, that's big thing right now. Kashlinsky had shown that their galaxies are moving a certain direction, not compatible to the Big Bang, really, but uh, might be compatible to that mega vortex thing that was on the Universal Cycle Theory book.
Right.
That's become very popular, and of course, multiverse is an oxymoron. There's only one universe.
Yeah,
That's what
yeah,
uni means.
yeah.
And so the multi is just nonsense, but what it is it's a kind of a reformist change on the Big Bang. In other words, they're trying to modify it in such a way that it will solve some of the problems that the Big Bang has.
Yeah, and of course you have the parallel universes, which is sort of interesting. Now, the other thing that's interesting, if you look at the year 2000, you see the Big Bang and expanding universe sort of dropping. Is that I would why do you think that is? I have my own idea, but what do you think? Why do you think that is?
Well, look at the multiverse and
Right,
parallel. They
right,
kind of go up while, just about 2000, or actually a little before that, they are underway. And
right. They are
so,
away. Yeah,
yeah, and they're kind of replacing that. In other words, it's just one of the things that they're doing. And of course, these all creationist theories. So was steady state theory. That's why it
right,
failed. It
right.
was hypothesizing, expanding, trying to fit with the expanding universe ideas. None of these are infinite universe
Right,
theories.
right, right, right. And then I think part of it though, and I don't know, it is my feeling that if you look at the year 2000 and part of the problems with the expanding universe Big Bang, I think even people in the mainstreams were starting to be skeptics of the Big Bang theory in some sense. In fact, let me go to another slide here. I'm going to take this down and move this. Um, Let me go to, I don't mind jumping around because here we go. I'm going to bring this up. So I also think that the 2000, you're getting more people, and I know you've been around longer than I have. I'm 61 now, so I've seen this for quite a while, many decades where I was actually paying attention. You see this a lot more. You do see. I mean, this is Forbes magazine. Is it time to dethrone the Big Bang Theory? A lot of times what they're talking about dethroning, it's putting in something more ludicrous or less ludicrous, but still ludicrous in its place. But you are seeing these words more and more. Do you get that feeling that at least people, maybe we are making a dent, that because it's the internet and people can search, that we're making some kind of dent in the idea that the Big Bang could be wrong?
Don't I wish?
Oh,
They
you
pretty
don't think
much,
so?
they pretty much ignore us because it's a total antithetical, and they're not going to be interested. That's how paradigm shifts are made, though. They are started by outsiders, and what we do is we bring out the contradictions. And I don't know whether we don't get credit for it. There's not going to be a reference on any of these if these are papers or news articles. They're not going to have a reference to anything that we said. But
Right,
you're
right,
right. You can, every time there's a problem. Like, remember, the big problem that the Big Bang had was that what the idea was that the expanding universe was supposed to give higher and higher redshift numbers with
right,
distance.
right,
And the only problem is that some of those numbers got so large at the end, once the Hubble telescope had got gone through it, they got so large that it meant that these galaxies were receding from us, going away from us at greater than the speed of light.
Right,
And
right,
you know,
right.
that's the universal speed limit, especially according to Einstein. Everything has to fit in with Einstein, of course. And so, what did they do? They had this problem of this thing going, these things going too fast. So what they did is they gave up on the distance function. And so what they
Right,
said, well, what is happening is space itself is expanding, and that's why
right.
these things are going faster than the speed of light. And of course, other BS like that, if you can swallow it. And that's the kind of, and Guth from Stanford had, I don't think he probably got a Nobel Prize for making up this story about the inflationary universe. That was what was going to save the Big Bang. And sure enough, it did for a while.
So yeah, I mean, we're talking about this really bizarre idea. How can space and time expand? Because one of the things with the philosophy of the natural philosophy of the idea of a Big Bang, you hear them say because I think it's a way for them to get around these problems, from them to sort of sweep them under the rug. Because when you talk about, oh no, for instance, they say this is what you hear: the size of the universe before the Big Bang was the size of a pea. Everything was inside that, right? And then it exploded. And then the question is like what we call the frontier problem, which is, okay, you have a pea, but where is it? You're saying it's the universe, right? Where is this pea located in a universe? What's around it? Not universe. And what they do to sort of try to get around it is what I've seen so many, and maybe you could talk a little bit about this. How can space and time expand? So they say, okay, no, the universe was the size of a pea, which doesn't make any sense on size, because if everything is there, forget it. You can't. Your mind will explode if you try to explain it. But they say the way we solve that is no. Not only did the universe in all its mass explode from almost a point, a very small size, space and time itself moved out. Maybe talk a little bit about that crazy notion.
Well, perfectly empty space has nothing. That doesn't exist. Okay, that's an idealization. That's and time, of course, is the motion of matter, and time cannot dilate or expand or anything like that. And of course, that's one of Einstein's greatest sins. In doing that, general relativity is what supports the Big Bang, just like special does. So that's what he did, and we're living with it now.
Yeah, I mean, I think the other problem I see is that when people are talking about, can space and time expand, you get this whole notion of Einstein, right? And that's
Right.
their space time. And of
Yeah.
course, my famous story with the space time is when I went to with Dr. Karazani, who doesn't believe in space time, doesn't believe in relativity, showed special relativity wrong in very numerous ways. And he said to the guy in 2005, it was in the museum, what is it? There's a museum in LA, and it had a 2005 Miracle of the Year, right? And it had that sheet, that rubber sheet kind of thing.
Oh
It
yeah.
was, and then you put like the ball
Sure.
in, it goes around. They said, "Oh, this is what gravity is," and he goes,
Yeah.
"What's this?" And he pointed to it, and the guy got so flustered he just sort of took a break. So it seems like the Big Bang and relativity have somehow gotten together, and two wrongs make a right. I don't know.
Well, no, the relativity, of course, is the foundation of the Big Bang. Remember, Einstein's particle theory of light requires that there be perfectly empty space, and so that light doesn't lose any energy when it travels from galaxy to your eyeball. And of course, nothing in the universe does that. Everything in the universe loses energy over distance, and light is the one thing that uh, Einstein pleaded for. This is called special pleading or an ad hoc add-on to make light a particle, and it's not. It's a wave in ether. So that's it. That's where he started, and so people have to understand that, and that's why you have the redshift is interpreted as a recession of galaxies. Now some of the
Right,
galaxies do recede and some come towards us, contrary to the Big Bang, because everything's supposed to be exploding, right? Apart.
right.
So, but Andromeda has a blue shift, comes towards us. And so Actually, half of the galaxies are going away and half are coming towards us by infinite universe theory. And what they're talking about is that they're all going away essentially.
Right.
And
Right.
that's how you interpret light in the particle theory, because the particle theory going through empty space, then it's supposed to get a redshift, although redshift doesn't occur in a particle. You have to have a medium to
Right.
get a Doppler effect. And so that's another one of the sins of the Big Bang as founded on Einstein.
Right, right. I know some people aren't hearing me directly, so I put this microphone right in front of my face. I don't know what's going on. It's a good microphone, but I don't have a sort of set. So hopefully you're hearing me a little bit better. But yeah, I think it is pretty amazing how um, they 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 take something like the Big Bang, they take something like Einstein, they put them together with all their problems, and then they say how they support each other. Now, if you're in the public and you hear these things, and you're not like critical thinkers like us who are looking at the actual logic. My friends who like science, they're not going to sit down and read a Borchardt book, or they're not going to sit down and read, criticisms of relativity. So when these people when you have the Big Bang and relativity sort of working together, it's going to be harder for the general public to think, oh, these things are wrong, even though they work together. But they are constantly, you see that, I think some of these ideas like the Big Bang, relativity, are constantly being propped up in mass media, right? I mean, you
Oh yeah.
hear that. I mean, you never hear like anything showing anytime Einstein is wrong or the Big Bang is wrong. We were wrong that we were wrong. So so they always come out and say, it's always good to be a skeptic, but again, Einstein's proven right
Yeah.
again.
Oh yeah. It has to. It's like a church, you got to believe this stuff or else,
Right.
and you can't be a physicist. I know people who gave up possibility of being a physicist, going to Berkeley. You remember Steve Bryant?
Right.
He was thinking of doing that, and then he looked at what they were into, and they were doing all this relativity junk, and he said, "Nope, I'm going to do math instead."
Yeah, to some real science. Yeah, it's sad. Okay, let's take a look at this. Is NASA's official view. I got this again from a lot of things you sent me, and I sort of cherry picked them. But NASA's official view of what the Big Bang Theory should be. And of course, there's going to be a lot of problems with this. And you sort of talked about this. Maybe you can talk about. I've got some pictures of the deep field, but talk about this picture, because it really sets up the demise of the Big Bang, really, right? I
Yeah, that's
mean,
right. Yeah, I call it the elderly galaxy problem. Notice where it says Hubble Deep Field there. Uh, the ultra deep field is not really seen, and you can see as you look further out, you're going to have poorer resolution in any case. But look at where it says Hubble Deep Field. That's where the purple is. I don't know if you can. Yeah,
right,
there, you're
right,
right
right,
there.
right there.
That is what we're seeing in the Hubble pictures, and they show, look at what they have there. They show galaxies just like ours over here.
Right,
No, in this area right over here in the Hubble Deep Field. This other
right,
stuff we'll talk about later. But
right, right. The Hubble
okay,
Deep
right
Field
here.
here.
Yeah,
Yeah,
I have got pictures from the Hubble, and let's see. I don't know if you have one of
I have one, I
distant.
think.
No, that
Oh, there
no.
we go.
There we go. This is a picture of 10,000 galaxies. If you put it on that sky, it's 1/10 the size of the moon. And
Right,
notice you have galaxies here that look like spiral galaxies. Now,
right,
our Milky Way is a spiral galaxy. It's over 13 billion years old. And what does this mean? These things are almost 13 billion light years away.
right,
So that means that light left when they were already 13 billion years old. So in any case, what we're talking about is galaxies that now have to be at least 26 billion years old, and and of course there's no end. As you see, there's tinier dots too that you're looking
right.
further and further away. These forefront ones are probably at 12 billion or something, but nevertheless, you've got galaxies upon galaxies, and they don't get thinner as you might expect. They get, they're just as dense as ever. And remember what the Big Bang said. You're supposed to, when you look out, you're supposed to see younger and younger stuff, like that one picture showed. You're supposed to have younger and younger stuff. Eventually, just have stars, I guess, or clouds of matter, whatever. And that's not the case. They don't ever see that, and that's a contradiction for them. These are not supposed to be this old.
Right.
Because remember, the universe is supposed to be 13.8 billion years old, the
Yeah,
same as our Milky Way, pretty much.
that's another problem that I think many people see, and that is, when any of us who are critical thinkers look at this, once you get into a critical thinking mind, right, you really start saying, okay, once you learn in your head that everything you've been taught in school is someone's truth to you, and they're not teaching us critical thinking. Like, for instance, Luis Sarobon from Rio, he is an engineering teacher, and he was teaching some things about physics and cosmology. And when he had his students look at the Big Bang, he required them to look at arguments against the Big Bang. Of course, he was eventually outed by 1/3 of his students who said he was teaching blasphemy, so he had to
Sure.
stop that. But that's the real way we should be teaching in the university, right? We should be teaching people to be critical. And if you look at the Big Bang just critically, and you say to yourself, okay, when the Big Bang happened, as it goes out, you get this, you got to think to yourself, what am I going to see? What's going to give me clues that we're in a Big Bang? And certainly one of them is every time they look into an empty a place in space that we think is empty, with a more powerful telescope, we see more galaxies, more objects that are as mature, it looks, as our own galaxy. And what do they say about that? What is mainstream saying to us that says, oh, when we looked in this deep field, the Hubble ultra deep field, and we see all these galaxies? What's their explanation? I guess one of the things that's happened, and it's interesting, I don't have a graph of this, but I think at the beginning of the 20th century, the universe's age was only in the millions of years, right?
Yeah, that's
And,
right.
and
Yeah.
and then it went up to 500 million years, then it went to a billion years, then it went to 3 billion years, and now we're at the 13.78 or 79, depending on what day you're looking at the Wikipedia
Right.
article about that. And so what are, I mean, you look at this, have you seen, what's their explanation? I don't know. Do you know any, what did
Uh,
they say?
not for that. I think they just ignore it pretty
They
much.
just ignore it.
Yeah,
Okay.
it's been out
Yeah.
quite a while.
Right.
During this century,
Right.
that
Right.
information was known, and now when they get the Webb telescope up next year, I guess
Right.
sometime,
Right.
then they'll see even more, and there'll be more spiral galaxies. Just like that's what we predict, of course.
Right.
Prediction is one of the things we do in science, and
Right.
that would be my prediction, and it's a pretty
Right.
easy
Yeah,
one to
that's not
do.
that's yeah, that's not hard. Here's another one I grabbed from you. It says 2 trillion galaxies. So this is less than point blah, 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 percent of
Yeah.
them. So talk about this. This is another problem with the Big Bang, right? There shouldn't be so much stuff out there.
Well, this is an artist's conception of
Right.
these things, and they like I said, there's 10,000 galaxies here. Now there are actually been observed, estimated that there are 2 trillion galaxies. So like I say here, it's 503% of them right here. But this is the one that you'll see, and when people start talking about the Big Bang, and I guess it's instructive that you have, like, for example, the Milky Way is in the middle. That's what that horizontal stripe is like right across the middle
Right.
there, a little
Right.
white, and so
Right.
on. That gets in our way, and what they do is look around it and see these others, and each of them is, there are all kinds of different galaxies. Of course, they're not all spiral, but
Right. Right.
that's what these little dots are all about here.
Right, right. So I'm going to get to another one here. We're going to look at the, let's see, redshift here. So we've talked about this. We're looking at the deep
Yeah,
field. We're
right,
going to, right. And the Hubble deep field, going back to this, is that one picture is here, where
right,
what before that, I guess this purple line, the HDF line here, the Hubble deep field. Before that, that was the edge of what we saw, right? We
right.
only saw nothing after that. Then we
Yeah,
got the Hubble telescope, and now we've gone this far. So what you're saying is, when we get the next one, we're just going to simply see more stuff the same way,
Yeah.
just further.
Yeah.
And I
See,
guess so. How,
the ultra deep field will have better definition. You'll see more spiral galaxies there, and you'll never see first stars, dark ages, radiation era. That radiation era is particularly egregious because it's the idea that energy is something. It doesn't exist. Energy does not exist. It doesn't occur. Energy is a calculation of matter in motion.
right,
So
right,
radiation era, these guys will talk about like they do dark energy. Dark energy doesn't exist, but they need
right,
that to propel the Big Bang. That's what the theory is about.
right, right. Okay, so let's go to the next thing, and well, let's talk about redshift, because that's really part of what's going. That's where the Big Bang comes from, right? Because you see redshift in all directions, so the universe must be expanding. Of course, it's very curious why we would see it in all directions. We just happen to be in the middle of the center of the universe, but we can throw that aside and say, oh, what luck! The other people, a couple billion light years away from us, they're going to see redshift on one side and blue shift on the other. But talk a little bit about redshift. How
Yeah.
maybe hear what this is showing.
It's a bit of a misnomer because you see these two black lines there that move from left
Right,
to right. They are just simply an indication of where the wavelength happens to be. So a
right,
blue wave can be shifted towards the
right,
red end of the spectrum. So it's shifted a little bit to the right. And you'll
right,
see that's what you're seeing with these arrows,
right,
at the lower redshift. And as you get further away, and it's a straight line, and it's just simply a result of tired light. So light over distance just simply loses energy, and one indication of that is that the wavelength gets longer. The way I explain it is this: in ether, a wave needs to be reproduced. Like it's like water waves. Do you get
Sure.
a perfect wave? The second wave, is it perfect? The third one,
Right,
is it perfect? No, there's a
right,
reduction in perfection, and
right,
that shows up as a lengthening of the waves. It can never be a shortening because that would be just not possible, because that would be a gaining of energy, and we don't see that.
right, right. So yeah. So this is just showing what the current explanations are and how they interpret that, right?
Yeah, right. And
So let's talk about blue and redshift. I think this is what this is about, correct?
yeah, right. If an object like in the center of these circles here are, when that moves left, you see that the waves are compressed because the waves are being produced now by that source in the center. Okay, and
Uh-huh.
as it produces them, it's still moving. So then the next one is closer to you. So if you're on the left, it's getting closer and closer, and
Right,
then on the other side, going the other way, they're getting further and further away. And of course, that's how a train whistle works, and car
right,
traffic going from
right,
low pitch when it's high pitch when it comes to you, and then lower pitch when it goes away.
right, right,
You can make
right.
that sound if you wish.
So what? Right,
There you
something like that.
go.
You go.
Yeah,
Yeah.
from high
Um,
frequency to low.
so if we look at, for instance, Jim Marison, he says, what if we just assume tired light as a postulate and not yet, it's not that is not yet unexplained. I mean, so we're looking at tired light. Talk to us about what the idea of tired light is. That is, if we don't believe the Big Bang is correct, we have to be able to explain what's considered, again, what is really happening with what we see as redshift, or that's why I put
Yeah.
in quotes.
Well, Hubble himself, when he was finding the redshift in these various galaxies, said that, well, maybe there's something we don't know. He never accepted the expanding Earth or expanding universe thing.
Universe, yeah,
Yeah, he never did, and well, he made a mistake. His first paper talked about galactic recession
right,
as a generalization, and there indeed was some recession. But as you look out further and further than he did, then you get this problem becomes magnified, and the whole thing was. He said, well, there must be some unknown factor that would cause this light to be tired. Okay.
Right.
As if it wasn't known. It was known at that time. It was
Right.
the second law of thermodynamics. Everything loses energy over time and throughout the distance. So that was already known at the time. It wasn't applied actually to this whole thing, partly because remember Einstein hypothesized a photon, which was massless. That means there
Right.
was nothing
Right.
in it.
Right.
And at the same time, he hypothesized perfectly empty space, which was massless.
Right.
It had nothing in it. So
Right.
you have something that is nothing and going through something that is nothing as well. So that's the magic of Einstein. Everybody believed it because
Right.
for reasons I explained in my next book, which you talk about later on, for those reasons, it was very popular and still is. And so the photon still exists
Right.
as
Right.
a theoretical entity. And so now like I was saying, I think that light simply loses energy over distance because it's impossible for waves to reproduce perfectly.
Sure. Sure.
And any failure in reproduction is going to be a longer wavelength.
Right, right. No, exactly. And I think even though we don't have a photon either in our model, what we have are waves of particles because you can't. It's just a different concept. But in both cases, you're going to have something in space that's going to slow it down, even in our model, because we have
Right.
infinite.
Yeah.
We have in a model, we have particles going through space, and they're coming from a place. It's not a wave through it, but they're going to be there. Space is not empty. We have
Right.
things below that.
Yeah.
So
And
here's
that's what Einstein's been proven wrong on empty space throughout the decades. We now in the within our own galaxy, we have all kinds of particles that we can identify. First of all, mostly hydrogen, helium, and then we also have gold, uranium, platinum
right.
from the supernovas that have exploded. Then that's how we happen to have these in our own solar system. So that's well known, and the
Right,
empty
right.
space that he requires it's just not ever been found.
Yeah, yeah, yeah. Here's an interesting comment, and it's getting into philosophy. Doesn't the clustering of galaxies automatically disprove expansion? I've never understood how mainstream claims there is both expansion and clustering at large galaxies. And actually, that sort of comes into let me put this here. How do I put this up there? Sorry, get this. Here we go. An explosion only has divergence. It's really that question really comes from this, right?
Yeah, right. An explosion can't create a damn thing. In order to create something, you have to bring things together. Like if you're going to build a house, what do? You get the materials together and you build a house. If you want to build a clustering of galaxies, you have to have, individual galaxies so they can form a cluster. They go together. They're not flying apart. That's why
Yes.
the Big Bang is utterly ridiculous because it's a coming apart, not a coming together. It's not even a good creation theory.
Yeah,
Creation
no,
always
it is. Yeah.
yeah, it's
I mean,
not.
here's the other thing that's really bizarre. Something that I still really haven't figured out is that if you have the Big Bang and you have things traveling away 13 billion years, how would we see at 13 billion years away from us early stuff? The early stuff is the early stuff that would be close to the center. It should be going out. I mean, why? You know what I mean? Unless, I don't know, unless these things were made and then 13 billion years go by, they don't change, then they're going to see, oh, when we look back, if we look back, let me see if I can bring this up again. And this is a problem I've had with oh crap. Oh, sorry. I've had with the Big Bang. Let me get to that. I'm going through the slides here. Anyways, the problem is that if you have the Big Bang and if you have this time that it takes, and if you have the traveling of an explosion, then you have to what we're supposed to be or think we're supposed to be seeing. Here it is. Sorry, folks. It's what you're supposed to be seeing. If you have these flat, the dark ages, the first stars. How could they be the first stars if it's been 13 billion years and we say stars don't last that long or whatever?
Well,
There's all.
they're talking about looking back in time, and which
But
is actually somewhat true. In other words, if you're looking back
of
13
course,
billion
yes.
years, you're looking back in time. If there really was a Big Bang, this is what you would see. According to NASA, it's totally reasonable, except for the radiation part, which doesn't can't possibly exist, and uh,
But
all this other stuff that they're showing obviously fits their theory, but they'll never see it.
I don't understand it because if the first star, well, I don't understand because the first stars would be, if they're moving away, aren't they? I mean, the first stars, and if they're moving away, they're going to be out there, so they've got to be going 13 billion years to get to where they are. Then there has to another 13 billion years to get back to us. The picture of that.
Yeah, the picture of
And
that, and
yeah,
that's why
and
it's
it's if
26.
you just that's why when I start to think of the Big Bang, it's just absolutely mind-boggling. I can't. There's so many questions of just the mechanics of what what they see, because the idea is they have again this idea that things have exploded. I'll get back to that one here. Things have exploded from this one place, but just that in itself, what you're going to be seeing at the tips is already 13 billion years ago. But it wasn't the right before the Big Bang. It's 13 billion years ago, 13 billion light years away from us.
Yeah, right. So it's got to be
So
26. That's what I
yeah,
always say.
yeah,
Yeah,
yeah, and of course that's another huge problem that I think the average person can figure that out. It doesn't take a lot of math. It takes what, high school math, with binomial equations, where you just figure out, there's two unknowns, or you got time and distance, and 13 billion years out, and then it takes 13 billion years to get. Yeah, it's
yeah.
just
Well,
like
it's just math. That's why they get the p thing. If you take anything that's expanding and you assume constant expansion, then what you do is you do the math, and you can get down to zero, a singularity, as Hawking used to say. And uh,
right,
it's too
right.
bad he never did figure out what the universe was about.
Okay. So let's see. All right, let's take a look at something else here that I glammed up from. This is sort of some of the history of more like how the Big Bang is related to the creation, right?
Right.
And again, folks, we're not here to discuss whether God exists or not, or religion is good or bad, or to criticize anybody who believes it. We're looking at the science of the Big Bang and how it related. I remember when I was young. I mean, I grew up in the '60s and as a kid in the '70s. I remember the Big Bang was in conflict even at that time with religion, right? Because it's science, and it was always hard for them to sort of, maybe they started looking at it more. But when I was a kid, where I was, it was like, religion and the science weren't linked together. Seems like the Big Bang and religion have sort of joined together. Is that what this is about here?
Oh, yeah. And see, Lemaitre's a priest who wrote this classic, The Primeval Atom, an essay on cosmogony. Now, cosmogony is not used very much because it assumes that the universe had a beginning. And
Right,
that's, of course, what creationists believe.
right, right,
And so that's where we start with the Big Bang. There might have been some others that said something, but basically Lemaitre, we call him the father of the Big Bang. And then Gamow and these other folks are all following into line and giving the same stuff. Now, at the very end here, this reporter McKenna writes this article reporting that the Pope says evolution, Big Bang are real. Okay.
right. I remember that.
This is from a guy who only imagines things. Now he's actually imagining evolution and uh, Big Bang are real, and that's kind of interesting. But the Big Bang is the last creationist battle, the last battle between science and religion. That's why
Right,
it's sticking in there so hard. Remember, it is very favorable to folks who are religious, as
right,
Lemaitre
right,
was, and that's
right,
why it's very, very strong. And that's why papers that try to contradict it will not be accepted.
right. So what you're saying is,
An
is it
atheist doesn't get invited to give talks at churches.
right? And I can say though there are people who are religious, and who say, yeah, there are some people I know who are religious, and they talk about a universe always being there. So I think there is a smaller and a growing group of people who are religious people, who do say that it's been around forever. So that it's changing a little bit. Let's go to another graph here, which I think is interesting, which is really the opposite of, I guess, it's where people are starting to question the Big Bang. Is that true? What this is?
Yeah, right. Now Vane
Oops,
was
sorry.
one of the first. He really hit it pretty hard. I mean, he showed the connection between theology and Big Bang stuff, and these are all people who doubted it.
Right,
Marmé, he's the Big Bang cosmology meets an astronomical death. So there have been plenty. Big Bang never happened. That's Lerner and so on. And
right,
even I mentioned a little bit in scientific worldview and so on.
right,
And this stuff has been going on a long time. There's been criticism. Now we're a little late. 1977. Remember that the Big Bang started with with in 1950. So
right,
I was a Big Banger in 78, and at the end of 78, I gave it up. But see,
right,
that's what you were supposed to be if you were in science. You believe the
right,
big
right.
guys.
Right, right. Let me get out of this so I can move this up a little bit here. It's sort of in the way. And you have, of course, Pletz and Borchardt in 2011. Where's the pointer for these things, folks? Okay, I won't worry about that. I don't seem to be able to find where that is. Oh, here it is down here. Pointer, laser pointer. There we go. Oh, there we go. So you have Bye Bye the Big Bang, Hello Reality.
Mhm.
Seeing Red is also, we've talked about that ourselves, but did you want to talk a little bit about ARP's work? Or what
Yeah,
is it?
yeah, that was great because remember the redshift was supposed to be only a result of recession.
Right,
And he shows that there are many objects in the sky that are related that have different redshifts, which are not supposed to have according to Big Bang. So that's a
right,
contradiction. And of course, the people would say, well, actually, this object is in the background, way far away, and it's
right,
not part of. But he's got quite a bit of evidence and got famous for doing it. And of course, got jerked out of the observe. I think what observer was it, Wilson or wherever he was.
yeah, yeah.
Yeah, he
He
had to
got
go to Germany in order to continue his work. So, and the rest of us, uh, Mitchell, I don't believe he's professionally uh, employed or was. And like myself, I'm independent from all of this physics and cosmogony pits as well. And so we were able then to talk about it without getting censored very easily. And that's why most of these people are kind of what are they, critical thinkers,
right. Yeah, absolutely.
or quite often like Alvin I think got a Nobel Prize, didn't he? I think for plasma stuff. And
Yeah, yeah.
so he's a big, he should be at the top of the list, for that.
Right. Yeah. It does. It's the way it is. I mean, even I know in expansion tectonics you had Warren Carey, and he was really respected in the regular plate tectonics. Yeah, it's not. They just sort of tolerated his view on that, whereas I think ARP really got drummed out, and he, it was the peculiar galaxies where he was seeing ties between the quasars and the galaxies, and people said no, they can't be because the shift is different. And he's saying no, they come from, it's an internal thing. It has nothing to do with moving or the distance or whatever. So yeah. Let's see here. What else do we have here? Oh yeah. Here's another question I think that or people are talking about, and that is, this whole idea. Well, there is a Big Bang, but there's also a big crunch, and I mean, this has a lot to do with your. I love the terminology of microcosms, macrocosms, unicosm. Obviously, you have to have, if you have a Big Bang, it has to happen. One of the, I don't know if you've heard of the Brame theory, the BRAME or something like that, where they have parallel universes like they're sort of like your hands sticking up, and when the two touch together, it causes a Big Bang. What about this idea that say, well, okay, yeah, it's not expanding, but it's going to come back in? What does neo mechanics? What does your ideas say about the idea of that?
Well, about the best I can say is that this idea maybe follows from complement complementarity, which is, as I define it, that the second law needs a complement. Second law says that everything in the universe is coming apart. And the complement is that everything in the universe that comes apart is going toward something else in an infinite universe. So
Right.
without infinite universe, that doesn't work. And that's why when they talk about the heat death of the universe, that would
Right.
be what they right now that's gotten very popular again.
Oh yeah, it has.
Yeah,
Yes.
there's I mentioned that in the blog and how silly it is, and so that's what they're doing. So Big Bang and a Big Crunch kind of fits that. Now, of course, there was no Big Bangs, and there's not a Big Crunch, and there's not going to be one. But I can see why people would do that in their initial thoughts, critical thinking about that. They what they really want to say was, well, how can we have this thing go on eternally? Well, because that's what we see. We don't see
Right.
any
Right.
Big Bang or anything. All that's just theoretical, and we don't have that. And so that's why they're doing that. Just like the multiverse, the parallel
Right.
universe, they're all attempts to reform the Big
Right.
Bang.
Right.
It's having the universe explode out of nothing is
Right.
totally asinine.
Right.
These
Of
guys
course.
actually believe it. They're getting money. The politicians give them money to study that stuff with that basis. Now, it turns out they often find stuff like the Hubble telescope sees more galaxies, right? And you can call it as a result Big Bang or infinite universe, but some of the money's worth something, well spent, because we do have some neat pictures. If you want to look at NASA's pictures, they're fantastic.
Right. Well, again, it comes down to here's what happens. One of the things I couldn't figure out, why would politicians give money for the Large Hadron Collider? Why would politicians, they don't know. I mean, you don't have physicists or people who think they know physics looking at these things and trying to understand them. What they see are jobs, right? They see jobs in their area. They see people who make these telescopes, who make the rockets to fire those things up. They see the workers who work on these gigantic projects to make these things. I'm
Sure.
just wondering what in the future we're going to use these things, or if we don't. I have no idea, but I think that's where a lot of it comes. I'm going to also take a look. I don't know if you're familiar with this, but I'm going to put this up there. But have you ever watched the Cosmology Quest by Randall Myers?
Yeah, that's a very good DVD. Is that on the internet now? I know at one time
Yes,
it
it
was.
is. Actually, it is, and you can look at what happened. Is when I was making my documentary, Einstein Wrong, I had seen this, and he was before me. I think he came out in 2004. So I finally got a hold of him. It was via the internet. I found out where he was, and I talked with him, and he told me that he made this. He spent a lot of his own money, I think over $1 million on this, and a lot of it was the graphics at the time. And he filmed this. He wasn't too thrilled about it. He's a composer. He's an American composer living in Italy, making a lot of money composing for films. I think he was doing it for Europe, but he's also now composing for American films, and not very well known. They're smaller, maybe B films, but people need them, and you can still make a lot of money on that. And so he spent his money to put together this DVD called Universe, the Cosmology Quest. And you can look it up. This is from Amazon, but you can't find it anywhere. But if you go to YouTube, that's why I have the little YouTube there. You can actually find it in a bunch of places. I talked with him. He says, I don't care. So put it on the internet. I don't care where it is. He used to have a website. He doesn't really take care of that website very much. But the good thing about it is out there. It's even out there in Portuguese because of, I think, Luis Sarabam from the University in Niterói across the bay from Rio de Janeiro. He had so many students, I think, working at it over the years. Some of them went in and they put Portuguese subtitles to it. So those people who speak Portuguese, they can watch it too with the Portuguese. But I think now subtitles actually are automatic. But if you go to the YouTube, you can actually find it in several places. I think you really can't. I didn't find just even this morning one place, but you can watch all 4 parts. I think what most people did at the time, YouTube didn't allow these 2 or 3 hour sessions to go on, so it was cut up. So you can go in, and I highly recommend anybody watch this. It's not going to win any film awards. One of the things when I talk with him, he influenced my film a lot, my documentary Einstein Wrong, is because he says, look, if I want people to go to sleep, at my parties, I show them my documentary.
Oh, really?
So the thing wasn't entertaining. And one of the things you want to do is make it entertaining. So I made sure, and a lot of people who watch my film, that's the first thing they say. They like the music, they like the human story. And then you ask them about the Einstein. Oh, yeah, that's pretty interesting. But at least they're entertained. They won't go away thinking it's a bad film. But if you are a critical thinker, this is a must. Take a look at it. You get really amazing people like Halton Arp's in it. Other people, well, he's an actor, but there are other people. Even Randall Myers, I think, is in it, who's the guy who produced it. So you can take a look at that. Let me see if there's something else I have with this. Oh, yeah, I will read this for people. This feature-length presentation is a unique mixture of human interest, and scientific documentary film. As for the first, it's for the first comprehensive documentary to deal with the major new approaches in a non-Big Bang cosmologies. It reveals several deep-rooted theoretical and observational controversies. This is a fact well hidden from university students and general public, which is told with clarity and conviction, and potentially leading to the downfall of the presiding Big Bang theory. At least that was his hope. The story is told by 16 world-renowned astronomers and cosmologists, such as the legendary Sir Fred Hoyle, controversial cosmologists like Jeffrey Burbidge, Halton Arp, and philosopher and telescope designer John Dobson, and astronomers. They go on and list. It says illustrated with 3D animations, which of course today don't hold up very well. He spent a lot of money at the time. I think he spent most of his money on the 3D animations at the time, and lush symphonic soundtrack, which of course Randall Meyer wrote himself. And so you go through it, and it's got like these pillars, and I think he makes this Greek type of pillar church, which is really, if you look at the graphics today, it just doesn't hold up anymore. But and then you can see it. Then it crumbles each time he makes an argument. It crumbles. So by the time you're at the end of the film, the four-pillared Big Bang is crumbled to the ground. So I do highly recommend you watch that.
It's neat to see all these fellows. Most of them are dead now.
Yes.
that were famous, in attacking the Big Bang, and like Halton Arp, Burbage's, and so on. They're not with us anymore. But just to see them in this film, I thought was very entertaining for me. But you have to kind of know who they were and what they did in order to be appreciating it.
Right. It's sort of like, it's sort of like the book on expansion tectonics that Stephen Hurl put together, which is all these people who you don't get to see and are pretty big in that area too. So I'm going to bring up the question that we're really getting to. And again, I want to welcome everybody. If you just hopped in, this is David D. Hilster from Dissident Science and the John Chappell Natural Philosophy Society, and we're talking today with Dr. Glenn Borchardt, because this is the internet and people pop in and out. We got our biggest audience. I think we're over 60 people live here today, which is really good for our group size. And of course, we'll see many more of you. So if you just hopped in, remember you can actually rewind it right here live and take a look at it and see it from the beginning. But I'm going to bring up another thing which a lot of people are talking about, which will lead us in till next week. But I want to open it more up to questions and discussion now, but let's look at this one part here, which is a big question that I have been seeing. If not the Big Bang, then what? I know that somebody, let's see if I can find this here. I've got some other questions here, but I'll find it later on. But this is a question that people are asking. Okay, Glenn Borchardt. Okay, Dave D. Hilster, you don't also follow Glenn Borchardt, so whatever Glenn says is absolutely true. No, come on, I don't. I think about everything that Glenn Borchardt says. I agree with almost everything. So, Glenn, what is it? What is there? If we don't have a Big Bang, then what do we have? Because that's, people say, well, Dave or Glenn, I do have I'm skeptical. I mean, there's so many problems with the Big Bang, but what do we have? What's there? Maybe,
of course, it's the infinite universe, and why would there be an end to the universe? Would there be dragons there? It's not possible. It's like when they talked about taking a boat and sailing ship around the Earth, is supposed to be flat, and you drop off the end. And so that's where we're at right now. And of course, we're all very self-centered. We think of everything from our point of view. Remember, whenever they show the observed universe, it's spherical, right? Because that's as far as we can see. And of course, the universe has to be infinite. It has to be infinitely in the macro and in the micro. They go together, as I point out
Right,
in my
right,
book.
and tell again. I'm being devil's advocate for
Sure.
people who don't know you and your work. Okay, it has to be infinite. Someone's going to say, well, why does it have to be infinite?
Why? Okay, because empty space is an idealization. It's something that is an idea. It doesn't exist. We it's part of the continuum between what we call perfectly empty space all the way over to perfectly solid matter. None of those two don't exist. Everything is in between. It's like the hydrogen atom, 99% so-called empty space. It's not really empty,
Right.
and there's always something there. And of course, I call it ether, and you can call it what you want, but
Right.
there's always
Right.
something there. So this is the problem with all of this creation stuff. Creation needs to have empty space.
Right.
It's an
Right.
idea,
Right.
an idea of empty space, and it doesn't exist. It's not possible. And so it's not possible for the universe to not exist.
Right. Right.
Okay.
Right. Well, and what's really, I always tell people, the question of existence can't exist without people existing. So it's sort of an oxymoron
Right.
because to question it, you have to exist.
Right. Exactly right.
So
Yeah.
it's like, yeah, it's one of those things that you have to think long and hard enough about, and someone has to propose it and get to that conclusion to finally say, okay, all right, I get it. So what you're saying is that empty space. If one of the things is with an infinite universe, and this is something hard, you have to sort of say to yourself, what is more acceptable, right? And when I'm talking to people on the street who don't know anything, they're not critical thinkers about science. They don't spend their time in doing that. And I said, one of the questions, is the universe made of one particle, right? That's one of the things we continually try to do, right? We had fire, wind, and water, and earth, or whatever, and then we got to atomic structure, right? So everything was made out of all of these atoms, and then we find out, oh, atoms are only made out of these three things. Right or wrong,
Right.
Again, I'm not saying that there are protons and neutrons and there are electrons. There's a nucleus, and there's something going around it. For us to say we know exactly what that is, probably not a good idea. But then they're going to say, okay, they came along in the 60s and they invented quarks. And I tell people, I said, look, quarks were invented to try to say that, oh, we have the periodic table of all the elements. Oh, now we can reduce that down to three things and describe them all. Now we're going to make quarks, and it's going to describe everything. It didn't happen that way, but I think that was the idea. It seems like the standard model, their idea is to go down to an ultimate particle that makes the universe. And there are a lot of dissidents who talk about that. Maybe you can, that also sort of has to do with this whole idea of empty space or not space or partless parts. Maybe talk a little bit about that. What do you say to a person who says, well, wait a minute, if there's an ultimate particle, that means we eventually are going to find empty space.
Yeah, they go together. So anybody who believes in empty space should be believing in a finite particle, an ultimate particle, should be believing in a Big Bang from a finite universe. Universe for them has to be finite. And so that's kind of where we're at right now. We're always still trying to find that, the God particle, if you will. The Higgs boson was supposed to be that, which was kind of silly because it wasn't inside anything. It was on the outside and weighed way more than it's supposed to weigh. But it got them couple $1 billion to do the hadron. That was fine. But no, actually, matter always contains other matter. And Aristotle said this as much. You have a piece of matter, it's XYZ shape, and then you cut it in half, and you get two bits of matter, and each one of them has so-called empty space. Now, empty space is just part of the universe that doesn't resist motion from other particles or other things as much as other parts. That's all it is. It's just like when I go through my doorway, that's in order for me to do that, there's got to be empty space there, right?
Right.
Is it empty? No, it's
No,
full of
of course
nitrogen,
not.
oxygen, right?
Sure, sure,
So
sure.
yeah, and that's the way the universe works. And I'm a real simple guy. Just the reason the universe exists, therefore it has to be infinite, as far as I'm concerned. I didn't always believe that, but now it's kind of clear because I haven't found any two things alike. And remember, the finite particle that people are imagining, each one of those finite particles are identical. That's what they
Right,
did. The
right,
Greeks did.
right,
Democritus, so on. They said, okay, we have these little tiny atoms, and everything consists of those. And we ended up using that name atom. And of course, there never was a situation in which they were all identical. You might say, well, every electron is identical to every, and that's not true. They've even located different kinds of electrons. Every hydrogen atom is the same. Every snowflake, no two snowflakes are alike.
right, right.
These have been studied. There's one guy, Snowflake, what is his name again? But anyway, he said, okay, we got 5,000 snowflakes here and no two of them are alike. And that's the
Right,
way. And
right.
some people with infinite universe theory, they'll say, well, that if the universe is infinite, then somebody like me is on some other planet in the universe. And that's not
Right,
possible
right,
because
right,
everything is different.
right,
You
right,
can't have
right.
somebody might be similar to you, somebody else talking about no Big Bang somewhere else too, but they wouldn't be identical.
Yeah, and I think that was one of the things I think when I read the universal cycle theory, where you really described the neo-mechanical world and infinite up all the way and infinite down. I mean, it really took me a while to understand that electrons are not identical, right? They can't be, and there's awful similarities between these. We have atoms that are awfully similar. But if you were to be able to get down, smaller and smaller, you'd find out that they're not the same. It's sort of like in the way, and people say, well, I can't really buy that because it's just so regular. I said, okay, look up into the sky. Do we have all the same suns? Are they all the same? I mean, the sun, and our planetary systems. It's like a single sun. It turns out that a single sun is not the most common solar system in the universe, at
Right.
least in
A
around
lot
our
of
area.
there's
It's
doubles.
two
Yeah.
or more. Yeah. And I'm thinking, well, that's fun. That sounds like, the atomic structure. And if you look at it, of course, no two suns are the same. People are going to say, well, there's similar kinds of things going on, but that really is something. Okay. I put down there, if you want to go to live.naturalphilosophy.org, what that will do is that will bring you into our green room. We have 1, 2, 3, 4, 5, 6 people here already in our green room. If you want to come on board and literally talk to us face to face, you just type that in. How does that work? Well, it actually, each one of these StreamYards, this one ends in literally 4Z32K under StreamYards. Yeah, if you go to StreamYard/U8KRZ4Z32K, you will get here because that's a unique identifier that will get you to this place where we have a green room. We have room for 10 people. And you can come in and chat face to face and tell Glenn Borchardt there is an ultimate particle, the Big Bang. No, I'm just kidding. You can say whatever you want. We're here to discuss. So we do have people in the green room, and we're going to maybe take some questions or comments here. But I have. Oh, yeah. I don't know if he does this. I'm going to have to start paying Ian to speak. No, but Ian is, I really enjoy Ian. He's sort of you talked with him before, I believe. So I'm going to bring up Ian here.
Sure.
Ian, how are you?
There
Hello.
he is.
I'm very well, thank you.
Yeah.
People perhaps will get the suspicion that I'm a planter for you, David.
That's good. And I have no problem with whatever you want to
We
call
need
yourself.
more. We need more
Yeah,
of
no,
those.
no, but you are here and you have really great comments, and you're not a troll, if you know what that means. So go ahead. I'll remove myself. Go ahead and make your comments.
I have a few comments on what has been said before, and maybe one or two sort of questions. Yeah, about the acceptance of the Big Bang. I mean, it's rather paradoxical that the term was invented as a pejorative term by Fred Hoyle, I think.
Right.
But it's ironic, really, that has led, I think, to a large extent, to its acceptance. I mean, it's a nice, term which can be used in marketing for the masses. Oh, Big Bang. If we had a more complex term, which didn't sort of ring so quickly, there would be possibly less chance that it would have been accepted. So that's a sort of an irony which I've developed, or I've looked at. The other thing is the Big Bang and special and general relativity. Now, it's quite true, what you've said, Glenn. These things have gone hand in hand, and you've described quite well how it's sort of consonant with the idea of empty space and just particle going through it, and there being no dissipation of energy. But I mean, these are two theories that have gained acceptance among professional physicists largely, and among the populace generally, and therefore they're brought together where perhaps that isn't always justified. One could just as easily find some discrepancies between the Big Bang and Einstein's theories if one wanted to. The most obvious one would be where he first postulated that the universe was static, according to his general relativity. And then he came later and said it was a mistake, of course. But so it appears to me that that's a bit of a sort of political statement as well, bringing two things together. Now, let me see. I had one or two questions here for you before I give up. But yeah, just one more observation, and I'll mention the 2 points, if I may. I'm a little surprised, or have been a little surprised, that the people who adopt some sort of creationist philosophy have not been more enthusiastic for the Big Bang in general. There are exceptions, but I mean, yes, Father Lemaitre, I suppose, was the originator of this idea of an expanding universe and so on. But it seems to me that many of the creationist type people are perhaps antagonistic to mainstream science, and therefore they reject the Big Bang. But one might imagine that it would be something that they would latch on to. Now, the 2 points. Yeah, I understood from what you said earlier that if, according to the conventional theory, if you observe a galaxy that is the same number of light years away as the ostensible age of the Earth, according to mainstream, 13.8 thousand million years, well, then the galaxy would have had to take that time in traveling to where it is now from the Big Bang, and the light would have to take that time coming back, so it'd be twice the distance. But I also understood, or I thought I understood from what you said earlier, that since these objects, many of these objects are spiral galaxies, such a construct would take thousands of millions of years to evolve. So that, again, that would be greater than the 3.8. So my question is, or comment really is, well, the first point, I think I understand what you're saying. The second point, well, I have a bit of a divergence there, because I claim that spiral galaxies are only really illusions. It's a bit hard to describe this in the short time that we have available, but really when we're looking at an object in the sky, it doesn't matter how distant it is, we're looking at a composite image. Any bright part of the image that we see happens to be distant from us the same number of light years away as that number of years ago from which the light left the object.
Sure.
You see that straight away.
Right.
But explain to some others. I mean, if it had originated earlier when the light would have been past us, and if it originated later, the light wouldn't yet have reached us. So therefore, if this object, which may be a sort of a spherical or elliptical type thing, is rotating, we would get a composite image made up of the light at quite different points, maybe millions of years away in time, and therefore we would get a composite image. And some computer modeling has been done actually to indicate that perhaps you would get a spiral form. So I wasn't quite sure of that sort of argument.
No, I don't know. I think that they're spirals. You can do some math if you wish, but I think the photos from the Hubble are very good, and that what you see is what you get. You know, like the light from one arm of the spiral has to leave at the same time as the light from the other arm, and so on. So I agree that they're spirals. Now, they're not all spirals, of course. There's a lot of ellipticals and so on, and so it shows that there's a varying type of age of these materials in the sky. You know, these various galaxies. So I don't know. I don't have any problem with when the light leaves. You know, it's like when you take a picture of somebody, the light left at a certain time. That picture, in my case, probably is pretty young looking, and so anyway, that picture, you know, covers all the light that was available at the time that picture was taken. And you're right. Yeah, and if you move towards that spiral, that's 13 billion light years away or away, you'll get a different light view. You know, like when the Hubble takes a picture of the same spiral galaxy on one side of, you know, the Earth as opposed to the other side or wherever they happen to be in the orbit, then you're going to get a slightly different picture. Probably not very significantly different.
I suppose what I'm saying in a way is that these are so enormous in size. They're not sort of like pinpoints that we're photographing. They're so enormous in size that the light has to leave the different parts of them at quite different points in time. But that, of course, remains to be quantified. Anyway, I take I understood your earlier argument correctly, did I? That you were saying it had to be twice the distance because of the time. You know,
to get here, yeah.
There are theories of expansion or something like that.
Yeah, you'd have to have that. So,
and it was an interesting point actually, which one of the participants put as a question, which I hadn't really thought of in such a form before. You know, you don't have a sparseness as you go out in the universe. If there really were a big bang, you would presumably get a more rarefied system with fewer objects. So is this something that you've considered as important as well?
It's a little bit hard to analyze that because what the Big Bang folks will say, well, if you look out further, the universe was more dense at one time, and you're looking back into the universe. And that would be their argument, I suppose. And the galaxies are closer together in the Hubble field, the deep field, than they are now currently in our own local area. That's probably what they would say. I don't believe it. I think the universe is infinite, and that's what you see is what you get. So you see more when you look at when the Webb telescope gets up, they're going to see even more. You can see those little dots in the current Hubbles. They don't show up as galaxies, but they're little dots. They're going to be showing up as spiral galaxies and ellipticals, and they're going to see, you know, that next stage, the ultra deep field is going to be just as clear as a bell when the Webb gets going.
Well, certainly, if they see things which are ostensibly a greater number of light years away than the 13.8 thousand.
Yeah. Oh, they'll just add to it. That's what they've done in the past. You know, they got to keep their theory going.
The Hubble constant has to be changed in value. Yes.
Yeah.
Well, an interesting thing too, Ian, is that Ray Gallucci from our group gave a talk one of the conferences, and he is one of those people that like to take these problems, like you mentioned, like the density. And so he not only wrote a paper, I believe he gave a talk on it. So if you go back to one of our CNPS, put in CNPS and then put in Ray Gallucci. He did calculations to show that what you saw in what you see in the deep field versus what you're supposed to see doesn't that actually his calculations show, and this is interesting to you, Glenn, too, that you could even add this in the future, is that Ray Gallucci's calculations from deep field versus close give him mathematically the same density.
Oh, that's
that it's
great.
that's
Yeah.
actually that he said, okay, let's take a look at that problem, and we should be seeing like that one slide I showed earlier on here, which was the explosion, right? Which you have is in one of Glenn's slides is an explosion. When you have something explode, it goes away, and you get less and less dense. So
Yeah.
that calculation actually has been, that's what he likes to do. So you guys want to check that out, or anybody here too. So okay.
I have noticed, David, that I mean, Glenn, you said this earlier, and you showed some graphs and so on. I've noticed sort of just a feeling, maybe 10 years ago, when I had some discussions about this matter, I was met by very hostile reaction among technical people, colleagues, and educated people, and so on. But I think I see a sort of a little chink in the armor. Now, there's slight doubts maybe, and if you raise some doubts about the Big Bang, you're not such a pariah as you were even a few years ago. Now, that may be imagination, but I'm getting that feeling just from responses I'm receiving from both
Really?
technical and non-technical people.
Yeah. Yeah. Okay. Well, that's good. It's I don't know exactly. I haven't studied paradigm shifts as much as Kuhn did, and I'm also interested in anybody has information on that as to when it softens up, when the paradigm softens up. How does that occur? How do we know?
Yeah, I did a video on that, and actually, I remember you made even a comment on it that, this makes sense. I did spend time doing that. I spent time looking at the Kuhn cycle, and I made a video of it. So look up the Kuhn cycle video with Dissident Science. So I did it on my Dissident Science channel. And what I found out, and I talk about that, and I actually talked about that in one of my, I think a couple weeks ago at the session where I actually did the talk on dissidents, is that we are in model revolution right now. We are absolutely in the model revolution. You go through the difference between us and mainstream is they look at model revolution having between Newton and Einstein, that Einstein was the end and got us back to normal science. Whereas what I see Einstein as being the problem of really in the cycle where it's not the end, but in the middle of it. So you have normal science, model drift, model crisis, and model revolution. So, we are in a model revolution because the model crisis we've been in. And I think that's what we can see. And one of the things that Ian is seeing, and I have seen too, because I've been involved with this organization since 1996, been involved with dissidents since 92, and I've seen absolutely. I think there's today in age, this whole idea of eyes wide open, where we didn't realize what's been going on politically in the world, that we've been being run by money and greed and corporations. A lot of people didn't see that. The young people our eyes are wide open to thinking that what we're being told, what we're being taught is what is somebody else's truth, and that when we actually go and look at it, we find out that there are problems behind it. So I agree, and I think we are definitely in model revolution. The reason is, as you can see, we're not only in Glenn, in my opinion, go back, anybody here, go back to 2 weeks ago, look at the CNPS or Dissident. I did a talk on where we are in dissident science today. Who are the movers and shakers? And of course, Glenn was one of them. Just want to make that point. So, so he doesn't go. Yeah. But anyways, one of the things I said is, look, we are not only in model, not model crisis. Model crisis is where you have all these problems like Big Bang. If you look at it, model crisis means the current model is just falling apart before our eyes. The Big Bang has done that. Relativity has done that. Then we go into model revolution. That is because now it's so bad that you have Glenn Borchardt with an infinite universe theory. You have Jeff Yee with his energy wave theory. Guess what those two things have in common? They're completely Newtonian. The de Hilster particle model. Yes, it doesn't have a photon. It's a different model, but what is it? It's an infinite model Newtonian model. It's a neo-mechanical model. What we're seeing is that the new models out there, we have Yonel Denou working on an ether model. We have Laurie Gardy. All of these people say there are no charge. All of these people say it's all Newtonian world. All of these people, most of them are all etherists, but at least they give a medium to light. We give a medium to everything. Everything in our universe, in our model, has to have a force. We have to be able to explain everything. So if for those of you, go back to that a couple of weeks ago, take a look at that. But in my opinion, Glenn, where we are, and I've looked at this, is we are in model revolution. And not only that, we are in model revolution where things are coming together already. If you were to go back 10 years, the people who were working on models didn't agree on anything, really. They all were what I call structuralists. Atoms are made of this. They're toroids, or they're this, or they're this shape, and they make this, and they come together, and they're rings, and that kind of thing. There wasn't really anything in common. Now, what you are seeing in modern theory, including Glenn's, my dad and I's, all these, the modern ones, they're all agreeing. They're all agreeing. A lot of them are agreeing on the infinite universe. A lot of, in the sense of the infinite levels, they're all agreeing that it's Newtonian. There's no magical thing like charge that we put pluses or minuses on. So I believe we're getting closer and closer, in my opinion. Now, how long that will take for obviously the world to accept it, that's a different a whole different question. But that's my take on where we are, right or wrong.
Yeah, well, that's I thought that was instructive, and I remember your talk now, and that everything gets scattered. You get all kinds of approaches.
Right.
Everybody's looking at different parts of the elephant and trying to make sense of the elephant. And we know the elephant that's presented to us is wrong, and now we're trying to get to the infinite universe theory, and we are reluctant to do that. It boggles the mind that the universe just goes on and on. But think of the alternative. How could it not be?
Right.
How could it not be?
Right. Yeah, and that's one of the things. And I think what's really interesting, that's why I think, I will say this, the next theory, whether it's, an ether theory, whether it's a particle theory like my father's eye, or it's a wave theory, whatever it is, it's going to be including the infinite universe theory, in the sense of the way I look at it is a framework. Now, whether or not you're going to interpret light as an ether, or you interpret light as waves of particles, because in our model we don't have a photon either. I mean, it's absurd to think of one particle can carry frequency. You can't do that. We have to have lots of particles to carry frequency in our case. But regardless of it, in my opinion, Glenn, that's why you're in history, written in history, it's going to be infinite. And it's the other thing that's really interesting is I've seen YouTube channels and people talking about the idea of fractals and how that things below us, like the atoms and everything that gets smaller, are all supported by things below that. And so this whole idea of fractal, like the fractal lady, Laurie Gardy, they're all coming to the same conclusions from different areas. It's just that Glenn has, in my opinion, formalized it way more than other people, and you sort of hang your hat on it. So I think that's interesting. Did you have any more other comments?
Just one last point, just really following on from your recent contribution, David. I don't know if it's a little fanciful, but and it can be dangerous to generalize, but there may be some connection between the acceptability of new models and political developments. It's been said that maybe the Newtonian system was developed in a system where thinking was very rational and everything was like set down in a Baroque way, and the music, Handel, was very ordered and so on. And similarly, maybe for the theories in the 19th century, of electromagnetism or evolution or something like that, they were sort of formulated in a Victorian age, a certain way of thinking. Now, maybe when the 20th century came, we had revolutions and we had socialism. And I know when I was sort of growing up, or a bit later, there was a great fashion in developing like Indian Buddhist, Eastern thinking. And they were saying, look, that shows that science is the same as this. It's just airy fairy, and it's not
energy and new wave and yeah.
So there's something in that, I'm sure, David. Although I do concede that one can go too far in drawing, parallel. But aid in showing this sort of shift in paradigms, as you say, that's
No,
occurred.
I think you brought up a great point. I have thought about that, and I agree with you. When you got into the '60s and '70s, you had this rebellion against the perfect world and suburbia and all that, and we started to look at it and psychedelic drugs and all this stuff. And actually, when I was a kid, I actually heard something that really rings true today, even in our model, like, oh well, the solar system could be an atom in some giant chair of some giant, right? And there, the idea of that is actually true. I think there was a lot of great ideas that came out of it, but I also think that it has influence and continues to influence this whole new age energy. I see something on Facebook right now that's trying to sell a new model of the universe that's more in this vein of the new age and energy. And I think the electric universe is another example of people trying to seek a new answer. I think there's also a tendency, Ian, that we want to find one answer. It's all energy, or it's all electric, or it's all gravitic, whatever. But I agree with you. I think a lot of this, there's part of that movement that got us into multiverses and, parallel universes and 11 and 20 dimensions. I think part of that comes from, I grew up a little later after you in the 60s and 70s, but when I was in sixth grade, I had three hippie teachers, and it was a whole different way. It was the environment and looking at it, and maybe, is everything in our head? Does anything really exist? So there was that questioning. I think for certain that kind of thing has been and influences a lot of the people's theories, and people's ideas.
Well, the story. If it ain't,
thank you very much. Anyway, thank you.
Thanks, Ian. You know the story. If it ain't broke, don't fix it. If it's broken, you fix it. And so that's what we're talking about, sociology and politics and so on. There's obviously a breakage there. And I think that science follows along with that. It maybe doesn't precede that. The Big Bang might be the last. I think it's going to be around for another 30 years. My idea is that it'll come down about 2050 when I'm gone. And that's because the whole we're talking about a sociological revolution that's international now, and we can't have infinite growth. We can have an infinite universe, all right. We can have infinite growth, and as we slow down in growth and we slow down in the population increase and so on, we're going to go through a severe social disruption, and it's going to be international, not just local. And it'll be local too, of course, but it's interaction. And so that's why the Big Bang is still hanging in there. Big Bang is a creationist theory. Most people are religious. They love it. They don't they don't deny it. There are a few that are young Earth folks, like my relatives were 6,000 year people. They thought 6,000 years was the age of the universe, was created just for them and so on. And that's gone for most part. It's a minority view, I think, among religious folks too. And
yeah, it's changing.
But religion, so even the Pope now accepts evolution and the Big Bang. And in regard to evolution, that's a good step. Big Bang, not so much.
And I've heard actually religious people talk about this, and I myself, I'm not, but I respect people's opinions. But one of the things I've heard, and I even talk with people who are religious, said, look, I mean, if there's a God and he's been around forever, right? Well, the universe has been around forever. It's infinite, and this idea that I think that's one of the things I'm seeing where people who are more modern and who are still religious, they hook on that it's everywhere. The universe is infinite. It's been here forever, and so the idea of this idea that the universe is infinite and it's been here forever is something I think that's changing. But revolutions will change when the mass of the thought gets to a certain critical point. And when that happens, it happens fast. It's sort of like gay marriage in the United States. We got to a point where it was a tipping point. It just rolled. It just rolled to the point where now the Pope is saying, we can't refuse these people because they're also humans created, whatever. But I think what's going to happen is there's going to be something that's going to happen. Whether it's a social revolution. Yeah, we are right now we're starting to realize we can't just rape our resources here and infinitely grow on a finite planet, that kind of thing. Is that going to cause that? What is it? Is it going to be that? I don't think we can predict what's happening, but I at least think in the science part, we are in model revolution. And not only that we're further along in model revolution than we think, because there's a lot of agreement going on than even 10 years ago. So, Okay, well, thank you so much. We're getting close here. I'm going to take him down, and he was my plant. Ian, the check's in the mail, but
Really,
but
the plant.
I do know there's. I think there's Hurley here. I see you there, and he hooked himself up. Did you want to say or come on? We have a few more minutes. I also see there's Bill Howell. Did anybody want to in the green room want to come up and say hello? Raise your hand or wave if you do want to speak. Oh, okay.
Bill, we want to see you.
Yeah, we have Bill, but we have Miss Hurley. Okay, I'm going to add him. Hello, Hurley. Hello.
Oh, there you go.
We're not hearing you. You seem to be.
You got to
You're.
turn your mute off.
No, the mute's off, but I don't think his microphone is working for some
Oh,
reason. Let's see if he can get that on there. I'll bring him back down until say hello. 1, 2, 3. No, you're still on mute, Hurley, but we're still not hearing you. You want to check your check that. I don't know. Bill Howell, did you want to say something or say hello? He's also in the green room. But anyways, let me see. I think I did have actually a question I did save around here. This is a question directly to you. And I thought there's a lot of things up there. And I appreciate everybody's comments. Again, everybody's participation. It says your 2015 people with puts, Borchardt blew me away. So that's good. I don't know if it's in a good way, but what do you think about Mandelbrot's fractals in the universe, in the universal wave series context? Does that make
yeah.
sense, or can you answer that?
Well, Bill, how you doing? Yeah, you have to read those papers. Steve Pitts is really into cycles, so that's what we were doing in those papers, and we do see some of this stuff repeating in cycle in geology. This is one of the things you have to remember that we were working on there. And as far as Mandelbrot, I don't know. Multifractal, well, of course, that's what infinite universe theory is, fractal, right? So the Elliott wave is interesting. I believe that's the economics, has a long wave thing, a cycle too. I don't think Steve has really covered that, and he would be the expert to do that. And be nice to see what he would say about that. And
So one of the things,
yes.
so the cycle, he's really talking about cycles as well, right?
Yeah.
Because that's one of the things about the universe. How do you say his last name for
Pitt, he calls himself Pitts.
Pitts. Okay.
I would do it like you. I would say Pitts, but he's
that's
a Pitts
okay.
guy.
Pitts. Okay.
You pronounce the way he wants it. Like Borchardt is Borchardt, and
right.
Howell
Pitts.
is Howell. And
right.
So on.
Right. So in that book, which again was really influential to me, not the cycle theory was very interesting. I enjoyed that, but again, it has neo-mechanics. So it's talking about the different cycles in the universe that we see, correct?
Yeah.
And that's more of Pitts's work.
Yeah, right. That's his, and I kind of follow along with that and check the grammar and stuff like that. He puts me on the papers and so on, and he's got a bunch of them published in the mainstream, which is very interesting. And,
but he also follows your work, though, right? He's an infinity person by far, right?
Yeah, right. You read the book,
right?
You'll know.
Right. Okay. I don't know. We're going to try you again. You want to try it again, Hurley? I know you have another one up there. Let me see if I can add that to. Oops, that's your. Okay, I can't do that. I'm going to read that. Can you unmute here? Let me unmute you, or I can't unmute you. Do you want to see if you can unmute again? You are now muted. You can unmute yourself, and maybe we'll get you. If not, nope. It says right now that you actually have used yourself muted. So. Okay, we'll bring you back down there. We'll work on that. Maybe hopefully see you next time because he will be back. I'm going to have him back here. Bill, did you want to come up and say hello at all? Are you there? There's Bill. Hey, Bill. How are you? Just wave. Hello.
There you go.
I'm not hearing him. No. I do see that your microphone should be working, but I don't hear you. But again, that's hello. 1, 2, 3. 1, 2, 3. You want to check your settings? There is a settings on there. You may want to check that. But anyways, I'm going to bring him down as well. For some reason, he is not getting that. It's not easy, folks. We do live in this world, so please forgive everybody. It's not anyone's fault, really. I'm going to see here. Again, we've been having a great audience, and I want to thank everybody. We still have a few minutes left here. We have like 3 minutes. And let's see if I can go through here. Alex. But I guess in the end here, you really have some predictions. This is the one of the things I have seen. I'm going to put that up. So if you want to read more about Glenn Borchardt, he's going to be back because I would not going to let him. Actually, I had the what's wrong with the inflation theory and Big Bang. They have actually a web page on NASA. Have you ever seen that? In fact, maybe I should show you that. For those of people who don't know, I'm going to do this right now, real quick. NASA has a page called inflation theory. It says, while the Big Bang theory successfully explains the black body spectrum, it says the cosmetic background radiation has problems. It's the flatness problem, the horizon problem, the distant regions of the space in opposite directions in the sky are so far apart that, assuming that the standard Big Bang expansion, they could never have been in a causal contact with each other. So it looks like that even, I didn't want to forget this, sort of throw this in the mix, that even NASA is having to deal with this. And it sort of goes along with what I'm going to ask you here in the end. And you've talked a little bit about this. For some reason, again, you, and I'm not saying this is wrong, but I don't have this. You are sort of got a timeline as to when you think the Big Bang will be accepted. Just give us, since we have you on, and that's your opinion, give us, again, you talked a little bit about it. Why do you think it's going to be 30 years and not in 10 years that the Big Bang will be really accepted? What's your idea about that, sort of in closing?
Well, in my books, I've shown this inflection point in 1989 for population for the globe. And that's the halfway point. If you take a sine curve, the inflection point is right in the middle, and the population was about 5 billion then. So what is the population going to end up being? It'll be twice that, it'll be about 10 billion. The last billion is going to take a long, long time, and you'll have a very gradual change. It's slowing down right now, not so gradual yet, but we're at 7.3 billion, which I predicted with that curve. All I did is a mirror image of what came before, which we do in science. And the population folks are always talking about highs and lows in population. I think it's right there on that curve. You can see it. Right. And so what happens then is that the reason you're getting a slowdown in population is that resources are becoming scarcer.
Right.
And that's what happens. And so people then develop more efficient ways of doing things, but there's still a resource problem. And so that's what actually happens. And so that's going to still take another 30 years before you're going to see a really big change in 30 years.
So
and I think a revolution normally takes a generation, and that's what we're talking about.
Okay, so what you're saying is that it's going to be linked. The scientific revolution is that we are building it now. I mean, we may be ourselves in model revolution and actually halfway through that, and that a model will be more and more accepted. But it's not going to really happen and go mainstream until these type of cycles are going on, right? So that's the kind of thing you're talking about.
Well, people have to be questioning everything, to question the Big Bang, to question religion, to politics, and so on. And that has to be done internationally. And look, at 30 years is a short period of time, but lots going to happen over that period, I think.
Right.
The next 30 years. Yeah.
Okay. Well, anyways, I want to thank you, Glenn, so much for coming on. I look forward to getting you back. You promised to come back and talk about the details of the infinite universe theory. Is that okay?
Sure can do that.
Right. And you also will be putting together a course again, but thank you so much for having you. I'm going to wrap it up here. Take care. You can go back to sleep now. It's 9 o'clock in the morning there. So, but if you haven't checked him out right there, you can go to scientificphilosophy.org and read all about it. He has a great blog, which I subscribe to, and I always look forward to his comments. And he always picks out some really interesting questions from people who are against what he's doing, maybe sometimes for, who are students of his. And you'll never be bored with his blog. So subscribe to that. And thank you so much, Glenn, for coming back.
Okay,
and we'll see you in a little bit. Okay.
Thank you for having me on. And that website, by the way, is just happened to crash just the other day. So we're trying to get it back again.
Yeah, I think it is. I haven't seen it, but if it isn't, but keep that in mind.
Just try it again. In a couple of days, it'll be up.
It'll be up.
There you
go.
And,
well, you know what's happening? We're drawing so many people towards you that we're crashing the system of so many readers.
Is that right? There you go. Hope you get it back too.
Yeah. Okay. All right. Well, thank you so much, Glenn, and we'll see you in a couple of weeks. All right, folks. This is David Hilster. I'm going to be wrapping this up again. I want to thank Glenn Borchardt and all my subscribers and all the subscribers. We're almost to 1,000 on the. You can always on our two channels. Here they are. Or here are two websites for the John Chappell Natural Philosophy Society. Go to naturalphilosophy.org or sciencewoke.org, and you can also go to our two YouTube channels, which we are broadcasting live to today, to the Natural Philosophy YouTube channel, and also the Dissident Science. And of course, if you don't know about it, if you're one of my subscribers, again, we're getting up to 3,500 subscribers. I want to thank you all for subscribing. I hope you're enjoying these things that we are putting out there, these interviews with some of these great critical thinkers. And if you don't know about the John Chappell Natural Philosophy Society, it is a great society. Check it out. And remember, I'm David Hilster. I'm your science therapist, trying to get you to the promised land of being critical. So remember, stay critical, stay thinking. Ciao for now.